Look at all this stuff. We're going to assemble this into the Troodon 2.0. So when I heard we were getting the Troodon 2.0, I thought it was going to be like 95% assembled like the other two Troodons that we reviewed in the past. I was a little surprised to find this. It's going to be a late night. So the Troodon is modeled after the Voron printer, the Voron 2.4 specifically. And the previous version of the Troodon didn't use quad gantry leveling like the Vorons are kind of famous for. So it'll be interesting to see if this one does. Now, right out of the gate, I've noticed that they're using 9mm belts, so the wider belts, and these are Gates belts. They're also using Moon's stepper motors. So they're, LDO is a great company as well, but Moon's is kind of, if you want to buy the best, that's what I would go for. And they've included those in here. If you've ever tried to price those out, they are not inexpensive on their own. And then we do have a hefty build plate. I'm interested to see how flat this is from the factory, because getting yourself a piece of machined Mic 6 or ATP5 for your build plate is one of the larger single expenses when building one of these machines. In typical Troodon fashion, and typical Voron fashion, the electronics are all underneath the bed. So underneath the heated bed here, which is a stationary heated bed, your electronics are contained within here. There's usually some fans to give it some active cooling. And so you've got your stepper driver board, kind of your slave board, to your Raspberry Pi. You'd be running Clipper typically. And then your 4 Z motors are under here. And so why do we have 4 Z motors? That's for that quad gantry leveling, so that if your bed was, all cockeyed for some reason, it can actually level the gantry to a degree to be completely coplanar with your bed surface, right? And then in addition to that, you still do the topographical mapping of the bed surface to account for any fluctuations there. So you get kind of the best of both worlds because you're not compensating any more than you have to in software. You're doing a physical compensation off the get-go. And on top here, this shiny gold stuff, this is a powder-coated PEI flexible build surface or spring steel sheet, and it's held down by a beefy magnet that's laminated on top of the build plate, the heated bed or build plate itself. Underneath there will be a AC heater, a silicone AC heater. I'm hoping that it's a Kinovo or other name brand. We'll get to that in a minute. And I also see off the hop, one thing that was a concern previously has been addressed, is that the build plate is grounded. And so there's a grounding cable here. Because we are dealing with AC, grounding is extremely important. I don't want to touch my build plate and get zapped. And then we've already got some of the plastic coming off of the side panels here. They are glossy, these little decorative rings. I'll leave that on as much as possible until the end. And then at the back, we have our power inlet and beefy switch. Enough yakking though, let's get to building. I'm gonna cover all those things as I come across them as we're going through the build. I'm sure I'll have lots to say. I myself have a 350mm Voron 2.4 at home. And this is 350 by 350 by 330 high in the Z. So very, very similar machine from that perspective. So I'll be able to do a fair like-to-like kind of comparison. So the instruction manual for the assembly, the user guide, a couple slicer profiles, as well as a Wi-Fi calibration, I think it said, but a Wi-Fi file is all on this SD card. I didn't happen to have a laptop handy, so I've got the PDF on my phone from the SD card, and we'll just follow along that way. I'm just gonna open these Allen keys, because the first thing we have to do is attach the uprights. So all of the motion bits, both X, Y, and in this case Z, they're all linear rails, right? Linear rails give you the most precise, clean, maintenance-free option. And so these make a little bit of noise, but they're smooth. There's no kind of like play in them or anything. So far, relatively happy. I hope that they are stainless or otherwise don't rust like early revisions of the old Troodons did. On one end, you'll notice that there are 2 holes drilled right through, and it's drilled through in both directions. So that is going to correspond to these M5 bolts that are in here on both this side and this side. There's 2 of them. So we're going to remove those, and we're going to bolt this onto there. So we will bolt these with these are called the blocks. So with the block and the rail facing front to back on the printer with this little adjustment screw at the bottom. Okay, so it should look like that, this being the front of the printer, this being the back. And so this one will go here. This one will be facing that way so that they're facing each other, front to back, and this one will go here. Okay, and I'll show you how the little button head screws go through the slot and through the holes. So what you want to do is don't take these all the way out. Just back them off here equally, and then those button heads are going to slide up and in here. Those button heads are going to slide up and in here. It'll make sense in a moment. So I'll bring this guy like this, and then they should be able to slide, there we go, right down like that. Make sure it's all the way to the bottom, and then through those holes that were drilled through the 2020 aluminum extrusion here, we'll be able to put the Allen key and then tighten those button heads onto the extrusion. Make sure they're good and tight, and then do it the opposite side as well. All right, 1 done, 3 to go. Okay, so far so good. Now the next step is the top metal plate here. It does have a wire routed through it for the LEDs, and on the front you'll see this little magnet catch, just like on the bottom. And then in our big bag of screws here, we're going to look for M5 by 10 screws. They should be button head. There we go, M5 by 10 BHCS, so button head cap screws. We're going to need 4 of them. And these are going to screw into the threaded tops of these 2020s. So 1 in each corner. Just wiggle it if it's not perfectly lined up until things catch. There we go. That one gave me some grief. So just tighten these all down, and then we'll go on to the next step. Okay, so we're going to take these 4 rubber foot pads, and these get screwed into the corners here. Exactly the same spot where these went in, but obviously on the underside. Just be careful when lifting this. Might make sense to kind of put something underneath it so that it can rest on that, instead of having to hold it with your hand, but screw those in just finger tight. Doesn't have to be anything crazy. So the next step, it does tell you to put down foam just to kind of protect the build plate and potentially the gantry. But we're going to tip this on an angle and kind of get it inside the frame here. Just make sure you've got the hot end at the front or facing the right way. So this frame, you can see there's little holes here. This here is going to bolt down into the top of these blocks. These blocks have threaded little kind of spheres that pivot here and allow it a free range of motion there. So rest this on those. And ideally, you'll want to orient those little spheres so that the threaded hole is, facing straight up to the top, or as close as is reasonably possible. On the bottom of those blocks, there was a little threaded screw that I mentioned. It's black. That applies tension to the ball at the top that I was referring to. So if the ball won't kind of freely slide around, reduce the tension by just slightly unscrewing that, and then the ball should freely move. And then you'll be able to orient the threads on the ball so they're facing straight up. Okay. So I skipped a step. After this top plate, we were supposed to put the pulleys on the top plate, but it's not too late, it's not a problem. So these are the pulleys, the Idler Pulleys, and then you need M4 by 30 bolts for them. And so these pulleys have little brackets attached to them. These brackets are also metal. All the parts so far have been metal of sorts, no plastic parts yet, other than these injection molded shrouds here. So these get bolted through 2 holes here, like that. So they would be in that orientation. And the orientation matches the wheel down here that you can see through the side. So the wheel is going like this, so this is going to go like this, and the belt is going to go up and through these. Okay, so 1, 2, 3, 4 in that orientation, like that. Okay. So what we're going to do here is intermesh these teeth like that, and then that will create the little loop that we can slide over there. Now you can see I don't have that much tension. I'll talk about the idlers in a moment. You want to make sure they're really loose. But we want to keep this as far down as we can get away with and be able to slide it over there. Now normally you would use a zip tie. This is actually really kind of cool. They've given you these little metal clips and you use a grub screw in them. And so what you'll do is with the screw facing the other teeth here, so facing into the printer, slide it up, do that little fold like I showed you, and then slide this down. And now it's holding those teeth intermeshed so that it can't possibly slide off. Then we would screw this in tight. And I'm just going to double check that I'll be able to get that on there, and I will, so that's good. So then now I can tighten this grub screw. You don't have to be Hercules with it, just tight enough that you're certain it's not going to go anywhere. And then kind of lift this up a little bit, slide that on, like that. Now just repeat that on all 4 corners. All right, I slid it over so I can have a little breathing room here. So those idler brackets that we installed up here, you don't need to tighten them down. Those screws were really long for a reason. So I've screwed them in just enough that the threads are kind of poking through the idler bracket, because we will never want to loosen these more than they are now. We will only want to tighten them. And that's how we apply the tension to the belt, the appropriate tension. Obviously, this is not right. And we want the right amount of tension, or equal amount of tension, on all 4 corners. We'll get there later, but I just wanted to mention, don't have these tightened all the way down when you're sliding your little clips over and kind of measuring out your belts. At this point, we can now manually raise the gantry. It's still not connected to the blocks or the rails, but using our hands, we can kind of wind the cables. So what you'll see here is that it's skipping teeth. Because there is so little tension on these, the teeth aren't fully engaged on the gears below. I'm going to put a little bit of tension on these brackets, just equally tightening both of the screws until the belt's at least not flopping around. Okay, so now we can use our hands in the large gears there and just kind of raise it up a little bit. It's not specific about how high to raise it, but I think it just kind of wants us to give ourselves some clearance between the gantry and the bottom of the unit. Now we can get this out of here. Okay. One thing I've noticed already is that this thick cable here is pressing against the belt, and in doing so, it's kind of twisting this belt a little bit, which is causing it to come into contact with the hole on the bracket here. So the solution here is to pull some of this excess tension that way or this way to get it out of here. So if I pull this down a little, now it's no longer contacting the belt. And then I could lock that in like that. So that should be okay. If that ends up not being enough, then I'll have to slide it through this side. But we definitely don't want that belt rubbing the frame as it moves up and down. There we go. Now we've got lots of clearance there. And then the excess is just down here. Okay. And again, it's just kind of floating there because our blocks are not connected yet. Okay, for this next step, we will need 2 M3x10 screws, but not quite yet. We're going to connect these cables into here first. Each of these are labeled. We can see B motor, A motor, there'll be a Y stop, and probably an X stop in here. There's the Y. And so those correspond to these numbered and labeled ports. So at the number 1, we have the Y stop. So that's this guy. And it goes in only one direction. So to attach the blocks, remember those ball mounts that we moved to point them straight up earlier? If you haven't done that, do that now. But for those, we're going to need M5x35 bolts. And they say elastic gaskets. Well, they have something called M5 gasket. It doesn't say elastic, but they are basically lock washers. So put a washer on each of them. So slide the lock washer over the bolt, put that down through this hole, it'll stick out there, and then we'll line that up with that. Okay, and just make that snug, and then I'm going to release the tension on that. Okay, so then we'll do that for all 4 corners. So once you've got the M5 screws threaded in there, they don't need to be fully tight. You need to tighten the screw at the bottom to secure that ball mount from moving around. So do that on all 4. And then diagonally tighten these, 1, 2, 3, 4. And then make sure that you loosen off that screw. What those ball mounts allow it to do is it allows the gantry to kind of like pivot and float on those blocks and not be rigidly secured. Because that's how it levels itself. It ends up actually contorting the gantry to match the angle of the bed. Okay?
What am I looking at?
Tape.
Oh, so again, just this guy?
Yeah. And let me just like move him further down even. Huh? It's not gonna fall. It's good. Okay. Ready?
Yeah, we're wrong.
Okay. So this big black one with the little vent cut out here, this is the back plate, like that. And it's got, you know, the sticker with the specs and the brand and everything there. So this is the back, the outside of the back plate. So on the inside of the back plate, we need to take off any protective plastic that's remaining. And then we're gonna take this foam tape. It says 1 millimeter foam tape. So I'm just gonna double check if they are different, and they definitely are. So the thinner of the 2 tapes, when I say thinner, I don't mean width, I mean like the thickness of it. You can see the difference in thickness here. So the thinner one, the 1 millimeter thick, and we're going to cover the perimeter in this. It acts as a gasket to seal this back plate against the back frame of the printer. And when I say back frame, I mean this side, because the front is facing me with the magnet catch for the door. Sticky side against the plastic panel. We're gonna go all the way around the perimeter. Except for where there's these little notches. We're obviously not gonna have any there, so we'll just cut it. And don't worry about the screw holes, because we'll still be able to get a screw through this / around this if we need to. So this is the air filter assembly. This is where the PTFE tube guides the filament into the printer, and it will exhaust the air out the back and put it through this activated carbon sponge filter, which goes in there like that. But we need to attach this to the back plate here using VHB tape that's pre-cut. They give you 2 pieces, so you get 2 chances at this. But essentially, just line it up with the bottom, follow the shape of the tape up the sides. Don't worry about gently setting it and like tacking it in place. You can kind of reposition it a few times, unlike the foam tape we were just using. And so just align it as best you can. If it sticks out on the inside of the filter, that's fine, you're not gonna see it. Like if it sticks out here, if it's proud on that side. If it's sticking on the outside, it would be visible from outside the printer. Okay, once you've got it positioned, just give it a firm press all the way around. Make sure there's a good seal. And then you can peel off 1 layer of the backing. If you have a razor blade or something, I find it makes it a lot easier to peel this stuff off. Just something to get under a corner. There we go. Peel that off. And then on the outside of the back panel, so with the manufacturer's sticker there, we'll remove the plastic protective film. So these threaded inserts should align with these screw holes right here and here. So this is going to go on the outside like that. And what we'll do is we'll take the M3x8 screws and put them through here and thread them into those and then bring it closer until the tape is all adhered to there. So this is going to get attached here with these T-nuts that are going to get inserted into here. So it's a tight fit, but you should be able to roll them in. Sometimes you have to get an Allen key in there and kind of coax them, but they should stay like that. And you'll want to align those with where the holes are on the back panel. If you rest the back panel down here and kind of tip it up, the hole is now right here and there. So just kind of play with the height until they're lined up. You can even poke your Allen key through here and kind of center it like that. And then do that for each of them so that they're at the appropriate height. So we haven't attached it yet, but it does say to plug in the filament runout sensor. So down here, just check the guide here. They call it FS for filament sensor, I'm guessing. Number 4, so that's this middle one. And then I've also plugged in the LED into number 2. So we have 3 of these sticky backed kind of tie strap type things. And so we're gonna put them to route these cables and keep them a little neater. So we'll put one right about here, like that. And then 2 right down the middle. And that will just allow us to keep some of this tidy. I didn't see it in the instructions, but it shows in the picture that the cables are wrapped in this little sheath here. So I will loosen this guy off. And luckily this is like split tubing, so we don't have to run the cables all the way through one end and out the other. So we can just slide them in like this. All right, so now we're gonna take this, they call this the PTFE screw bracket. Essentially, this is going to get screwed into somewhere over here. So there is sticky tape there, but we can just kind of puncture through that. It's threaded in the metal frame behind there. There we go. So tighten that on there. It also helps because this is like another point that's pinching the back plate on, because there are no, we didn't install any T-nuts on the top here. So this does kind of double duty. And we'll need to make sure that it's oriented like that so that the PTFE tube can come out here and go through here. Now, what PTFE tube? So the tube that's going to lead to the hot end. So this is going to route our filament all the way into the chamber to the hot end. And so it will go kind of like this. You don't want it to be a super tight bend. We're going to install another one of these roll-in nuts right here to attach the spool holder. I think earlier I had said that the runout sensor was going there, but it's not, it's the spool holder. And this is like a injection molded plastic of sorts. And those 2 little teeth here kind of guide the alignment. So it slides in like that. And then our bolt is going to go through there. So kind of in the center here, we want this. Now I have been having a difficult time getting these to roll in there. We don't want it to slide down here as we're trying to get it to lock in. So I'll put this in here. Just kind of slide my finger underneath it so that it doesn't fall down. And then I'll put this in the threads and just kind of pry it back until it's in place. You should be able to just press them and they flip in, but there we go. Sometimes they need a little bit of coaxing. There, perfect. And then just somewhere, whoops, you just go down just a little bit. That one's really tight. I'm gonna have to coax it down until it's about in the middle. So I can't slide it because you might be able to see there are 2 screws that are threaded through here. Those screws hold on the rail on the other side, and the one screw is a little bit proud. This screw is fine, but this one is blocking this from sliding any further down. So I'm gonna have to take this out and then manually move it below this protruding screw. So there, something like that. So we've got our M5 by 10. I'm not sure if I said it was M5, so it is different roll-in nuts than we were using for these 6 on the back panel. So make sure it's an M5 roll-in nut with an M5 by 10 bolt. So we flip the machine back around, and now we're going to install the hinges on the doors. So in the picture, it shows the doors like this, with the smaller notch at the top and a larger notch at the bottom. So keeping them oriented like that, we're going to have hinges. They have these hinges here. and they're going to be attached here using M5 bolts. They're M5 by 16. And on the back side, we're gonna have a lock nut. So an M5 lock nut here. So just before I thread this through, I just wanna peel back the plastic because I hate having to try to rip this plastic off when there's a hinge or something on top of it. So just peel it back there, but leave it on the rest because these will scratch pretty easily, especially as I'm laying them down on top of other stuff on the workbench here. All right, so I've got the hinges on all four corners. As you're installing them, just keep visualizing and placing them in front of the printer to make sure you have the orientation right. The hinge should be facing you with the small notch at the top. That way, this is basically going to get bolted on here onto the rail and be able to swing open like that, like a French door, okay? Now, not done. There's plates to go on these notches at the top and bottom. So there are two different metal brackets, or two different types of metal brackets here, or metal plates. There's these angled ones. These angled ones are going to go on the top here, and the holes line up like that. And these ones with a U shape are going to go on the bottom here with the larger notch. So these are going to attach with smaller screws. They're M3 screws, so M3 by 10, I think. Yep, M3 by 10. And then the M3 lock nuts on the back side to kind of hold them on. Okay. Same thing, I'm going to peel the plastic back on both sides. So the next step, we're going to insert these M5 T-nuts. So these are the ones with the larger bore there. And it does show them in the picture that they will fit in this orientation. You could flip that top one 180 degrees if you wanted. And that's to align with the hinges. So obviously I've got them a little bit low, so I'll stick like an Allen key in there and just slide this until it's at the right height and it's attached to that magnetic clasp there. So that's why these metal brackets sit proud of the top and bottom. So align those and screw them in and then install another set of two on the top and bottom. Now, when you are installing them, just make sure you like stick your finger or something in there in case when you're putting it in, it slides down because it will kind of disappear into here and be kind of tricky to get out. Okay, so the doors are just resting on the bottom here and held by the magnets. I've aligned all the T-nuts as I mentioned, and you'll notice that this sits proud of the frame here, whereas here it's kind of like sunken into the frame. So there's these little spacers here that go behind the hinges there to kind of bump it out so that it's even from side to side. And through there, we'll put another one of these M5 by 16 bolts through each of those. Now, the instructions do tell you to install the foam gasket material on the underside and inside of the frame before doing the doors. I'm actually going to do it in the opposite order for fun. So I've aligned the doors so that there's an equal amount of space from the top and the bottom, or as best as I can. We can always come back and realign these a little bit more if we need later. But you can use these handles to kind of open the doors. And then this 3mm tape, so the thicker tape, not what we used on the back, is going to go right on the underside here, flush with the front of this, okay? And then that way the back side of the door will kind of just press against it, creating a seal so that there won't be any gap, so you don't have any air escaping. Now, as per the instruction manual, we're going to cut it right here. We'll start it again over here. And at the bottom, it shows you stopping where these rails are because it needs to be in line with the front of this bottom plate here, not on here, just on the metal portion. So we'll go from here to here, and so on, right? And then all the way up the sides, there's no obstruction, so we can do one solid piece. All right, so I've got the foam installed all the way around. Now you may find, especially at the hinge here, that it's kind of, you can see it's getting tense right there. So it is pressing against the foam, which is actually what we want. It needs to be tight against it. In some other areas, I might need to bring the foam just a little bit further forward if it's not completely flush, like right here. So luckily you do have a little bit of an ability to peel and reposition. You're only gonna get so many cracks at that. But the idea is to kind of make sure that there's a seal as best you can all the way around. So this smaller piece, we've got 3 pieces left. This is the top. I'm just gonna put this aside for now. And then we have these 2 sides. So the sides have this notch out of the bottom here. So that is the bottom. And on the side of the printer, there's a lip here behind this plastic piece. So this is going to go down there like that, and then up like that. And so now we can see we're gonna attach this with M3. These ones are threaded, but down here, we're gonna have to put in some T-nuts. So here by the little notch outs, I've peeled up the plastic. We do have to put some more 3mm foam tape along there. And that 3mm tape is going to get pressed against the inside frame of the printer. So as we put this panel here and slide it in and press it like that, it will create a seal at the bottom. And then we'll be having 3mm tape all the way around the inner edge of this. So only the bottom will be on the plastic panel itself. So after you have the 3mm foam tape on the bottom, this would kind of lean it back, slide it in, and then lean it forward. And then these little these little plastic sticks here, which also have protective film on them, these are going to go on the inside between the clear panel and the printer, all the way around, one on top, and then you will screw the bolt through both of these and into the threaded holes or into the T-nuts. Just make sure that they're aligned properly. We can see that one's too high. So 1, 2, 3, 4, 5, 6 T-nuts, top 3 are threaded, and then you'll need 3 of these. All right, so there's one side done. I've taken all the plastics off, and I've started to take the plastics off some of these bottom pieces as well as they go around. So now we'll flip it around and do the other side exactly the same. Okay, now we're gonna install that top plate that we set aside earlier. And this top metal plate here is already tapped, so we don't need any T-nuts or anything. Just M3 bolts again through each of those holes. Just pull off the plastic first. Okay, on the front here, let's just remove the plastic. We've got this little screw here. We've got to take it out. And this screw is going to be used to hold the screen hinge onto the printer. So I've inserted that bolt that we just took out through there and out the back. Before we actually install this, I'm going to connect the cables. So just tipping the screen directly forward, plug the cables in exactly how they line up. The cables aren't labeled or anything. The ports on the back are labeled 1 and 2, but they just go like that. And then kind of tuck them back in as you slide the screen back and then bolt it back on. So we have these little corner brackets. This is just to pretty up these corners here where the 2020 is still visible. So they go like that. Now they do have little like push teeth here on one side. So I would line it up in this case with the front and then just push straight towards the back, and they should, with a little bit of force, click in like that. All right, some finishing touches. At the back of the heat bed, there is a small receptacle to put this little metal post, and it is right here. There. So that post goes in right here, and there is a switch underneath the bed there. And so that's the post that the nozzle will actually tap on to figure out where 0 is. So it'll use that to home the Z, essentially. Now in the manual, the next step, it tells you to level the printer using the feet. So the feet do have a little nut underneath there, so you can unscrew the foot to raise the corner, and then tighten the nut up to the printer to kind of lock the foot in place. I've plugged it in, and I'm about to turn the switch on the back. I'm a little concerned. Let's see. It's alive. Well, that's a good sign. Event notification, filament error on extruder. Okay, I'm wondering if that means we're, out of filament because there's no filament in the runout sensor, but there we go. There's our on-screen menu. All I want to do is move, if it'll let me, I want to move the printer in the Z direction. So let's go to move. We'll go down to Z and plus 25. Now it's not going to let me do that because it doesn't know where home is, I think. Okay, well let's try homing all. Let's see. Interesting. I thought it was going to use the little switch at the back to home, but it used the sensor to home. Let's open this up and move the Z up to give us some space. Okay. And I just wanted to do that because I saw some plastic film on the underside of the PEI sheet. So one side of the PEI is your PEI, one side of the flexible sheet here is a PEI sticker, and the other side is the powder-coated textured PEI. And then under there we have the magnetic sheet. Okay, so we have a few extra pieces. Nothing alarming, I haven't missed any steps. We do have an extra one of those little metal posts for the switch at the back there, and a couple other odds and sods as far as screws and nuts are concerned. One thing to note is that there is no bracket to hold the filament runout sensor. It just kind of floats there on the filament. You feed the filament through it and then through the Bowden tube. I originally thought there was going to be a bracket for that, but there isn't. I have a big sticker here, which we could place on the inside of the back wall if we so desired. And I have a significant amount of the 1 millimeter thick foam tape. So we used 3 millimeters, if you recall, on the bottom of the side panels and all the way around the front doors. And we used 1 millimeter on the back side. There's probably 30 feet or so of this left. I thought it was going to call for this all the way around the side panels and on the top panel. I'm looking at the top panel, there are some gaps between the bolts, kind of like it's a little flexy. So I may actually take that off and add some 1 millimeter foam tape just to make a good seal around there. The more we can seal the unit, the better, honestly. But this just leads me to believe that I had missed a step, and I double checked the instructions and I hadn't. So at this point, we're going to run it through its paces. We'll spend the next week printing a variety of materials, both ABS and PLA, maybe some PETG, depending on the nozzle it's got there, which could very well be a hardened steel nozzle. But if not, we'll throw one on there. It appears to be a E3D V6 style hot end, but we might even run some abrasive materials or engineering, glass-filled composite materials through it. But we'll come back in a week anyway with a bunch of prints and my thoughts about my experience with the unit. And in many cases, I'm going to draw direct comparisons to my own Voron 2.4. I happen to be using a Dragon with the Orbiter extruder, but just to do a apples to apples kind of comparison, since that's what this is built to model after, I think that's a pretty fair comparison to make. So we'll see you back in a week. All right, we're back. It's been a couple weeks and we are in our new area of the shop here, so a little bit of change of scenery. And we don't have the printer. As I said, it's been a few weeks and that printer was put right to work in the shop and has been printing almost constantly for the duration of that time, after we did our test prints, that is. And it's kind of replacing the original Troodon that we've been using quite a bit in the shop over the last year and a half, I guess. Maybe a year, I can't remember. Anyway, first prints here were with PETG. All of these prints were sliced with Prusa Slicer using the base profile, and I think it was Prusa Slicer 2.6, just to get the version correct. And this is PETG. There's black and kind of natural or clear PETG. They turned out great. We printed these at 245 degrees Celsius and 200 millimeters a second. Now, this is a pretty simple print, all things considered. This one considerably more complex. So you do have a lot of retractions between these little pegs. There is some zits, so we did have a little bit of like oozing and some stringing between some of these kind of support posts. No charring or anything really, luckily. But PETG can be a little temperamental at times, but it's strong and it printed reasonably well anyway. Moving on, we cranked up the difficulty and used some TPU. Now this is a stiffer kind of TPU, it's not like a Ninja Flex or something that's like an elastic band. But even still, we found if you printed too fast, you'd actually get jams inside the extruder assembly. So something about the filament path in there is not quite tightly constrained enough that it would kind of buckle and jam. So this was printed at 235 degrees Celsius and at 60 millimeters a second, again, using the base profile. Because we can't see any of the retraction paths here, we don't see any kind of stringing or anything, but that is actually on the inside. So there is some stringing as it kind of travels from side to side. This unfortunately couldn't be printed in vase mode, which obviously avoids retractions entirely. So we can definitely tune this material a little bit better, maybe adjust the temperature slightly, but all in all, like I can cut these off with little flush cutters and it's not a big deal. It doesn't impact the functionality of the print. And the outer shell looks fantastic. And then we moved on to some carbon fiber PETG. So this is, I think it's about 5% carbon fiber, give or take. We did swap out the nozzle to a hardened steel nozzle just to be safe. You know, carbon fiber is abrasive and a standard brass nozzle will, you know, be worn out in no time, even with a low percentage of abrasive infill or abrasive filler. Whether that's glass fiber, carbon fiber, bronze, was it bronze or brass? I can't recall, where it actually had particles in the print. Even glow in the dark material can be abrasive, especially if it includes strontium alumate as the chemical or the ingredient that makes it glow. It's kind of like got a sandy texture to it and it'll blow out a nozzle. So swapping with a hardened steel nozzle, we've got 3 prints here with carbon fiber PETG. This is like an impeller, turned out great. A little bit of minor stringing between some of the tops of the impellers, not a problem though. Nice smooth surfaces, nothing to write home about, turned out perfect. And then here is just like a bracket, a little adjustable bracket. I think it's actually a mounting bracket for a hot end, if memory serves me right. Turned out great. What's interesting about this is there is a little bit of ringing here on the front and the back, which are the 2 sides that I would expect there to be ringing, if any. So you only have the tool head moving in the X direction, so that's lighter. Whereas in the Y direction, you have the entire crossbar moving forward and back. So there's a lot more inertia there. There's a lot more mass moving back and forth. And so as you come to the front there, that mass has to stop and suddenly change directions and you can end up with a little bit of a wobble. Luckily, Clipper has input shaper, which should be able to tune out the resonant frequencies. So I'm gonna look into doing that on this printer, which should help kind of avoid that ghosting on the front and the back there. The sides have no indication of that at all, as expected. And the top, beautifully buttery smooth. And this was printed at 150 millimeters a second at 245 degrees for this particular material. Actually, all of these were 150 millimeters a second. And then just a smaller print to show you kind of the level of detail. Couple small issues with this one. I think, you know, with PETG, it's a bit of a trade-off between temperature and cooling and kind of the bond strength of each layer. If you cool it too much, you'll have very poor interlayer bonding. But if you don't cool it enough and you're doing steep overhangs, you might end up with like a bit of a droopy surface. So we have a tiny, tiny little droop under the chin. And there's 2 spots past the eyes where it's a little bit under extruded. So as it retracted and then went to move across the eye and then continue, it likely oozed out of the nozzle a little bit, so it didn't have a full nozzle when it continued the next section of the line. So we could end up tweaking the temperatures a little bit maybe to avoid that, but it's a very, very minor issue. But on a print of this scale and with this level of detail, an issue like that really kind of irks me. But I'm not going to fault the printer for that. Considering this was done at those speeds, it's fantastic. And it's a big printer. You know, it's not, I wouldn't say it's the printer I would choose to do small detailed prints like this. Maybe if you wanted to do 100 of them on the bed at a time, it might make sense. Otherwise, I would just choose a smaller printer and not have to heat an entire bed like that size to do a small print, but also just to be able to print faster with the same level of detail using a smaller massed printer. But anyway, it's a capable machine. As we looked at the hardware when we were assembling it, it's a significant improvement from the first one. It actually makes some improvements in my mind on the actual Voron design, specifically the kind of pillow ball mounts on the Z-axis on all 4 corners. That was a really nice kind of ball mount mechanism. The original Voron has like the printed kind of ball and socket, almost like a shoulder socket mechanism there. So that's just, you know, smoother. Does it make a difference? Probably not, but it's just something I liked, and it's nice to see that they're, you know, more closely following the Voron design and making considerable improvements to their product. Hopefully you found all that useful. Remember to like and subscribe and ring that bell if you want to get notified when we upload more videos. See you next time.